Hello, this is Salah. We'll talk about Variobase abutment exercise. All of you guys reached the stage of mounting the master cast against the mandibular cast, and now we wrote a prescription form and we already submitted this to the lab. And what's going to happen in the lab, so if you go get the screen here, some slides to show you. So the technicians will go ahead and scan your cast, and they will have to digitize your record, and they got them mounted on virtual articulator. Then, as you can see, the scan body here, it tells them where the implant platform is, and based on the available space, they will use appropriate Variobase abutment for your restoration. And then this is the Variobase abutment, how it looks. We'll talk about abutments. I'll do a quick revision really quick here. You can see the screw, the basal screw. Any screw goes to the implant body, we call it basal screw. And then this is why we have a tissue moulage in the cast, because the technician will expand the soft tissue. So this is the emergence profile. And you can see the screw here. The yellow part is the Variobase abutment. The implant is down there. This cross section of the designed screw retained restoration. And this is the planned designed restoration, multiple views. And the only reason we got a screw retained restoration because the implant placement was so accurate that the central fossa is in with line with the implant fixture, so we can get a screw retained restoration without having the access screw hole coming from the facial side or from the lingual side. So the forces directly will be transmitted to the implant body, which is very favorable. So we milled 80 crowns, 160. Each student will get 2 crowns of the proposed design. And now on your cast, we will try to fit the milled, it's PMMA crown, because like we cannot afford zirconia crowns for milled twice for each student. So we're gonna try to fit this crown to the abutment, the Variobase abutment, and you can see the basal screw here. And this is the abutment. And deliver this. Once you fit it in the cast, we will be transmitting that crown to the patient, deliver that crown to the patient and torque it down to 35 Newton centimeters. So as you can see, and this is what you're going to use. This is screwdriver to drive the components in and out. And eventually, I'm going to use the screwdriver. We're going to torque it to 35 Newton centimeter. I will show you how to do that. So, going back to our model, the exercise is not that accurate. I should admit that. So we will do things here that we are not supposed to do it clinically, but next year hopefully we'll avoid those issues. First of all, before we start, let's talk about abutments. As you can see, here I have the Variobase abutment, a temporary abutment, and UCLA abutment or cast don't want to stay. So this is temporary abutment used for temporary crowns. This is Variobase abutment, and this is UCLA abutment or gold abutment, castable abutment. So you wax your restoration. As you can see, there is a bezel screw in each of one of these. Today we will focus on the Variobase abutment. As you can know, or you notice, if you look at the abutment, it has two components, something. So let's draw an abutment for you here. So the abutment basically, it's not the crown, it's not the implant, it's something that connects the implant body and the crown together. And the screw is the clamping force between the two components. So if you want to draw a sketch for an abutment, it will have something like that. Very basic drawing. So we can talk about parts. So let's talk about the bottom part. So type of bottom parts, either engaging or non-engaging. The non-engaging abutment, they don't have the anti-rotational feature that interact with the internal connection of the implant body. The engaging abutments, we have those anti-rotational features which are very helpful. The only time that I use non-engaging abutments when I use screw-retained fixed partial denture. So when I talk restoration and abutment, they have to go at the same time. Sometimes the implants are not parallel enough to get you passive seating. So there is a reason why we get rid of this part, use non-engaging abutment and screw-retained restoration for fixed partial denture, multi-unit restoration. Otherwise, we always recommend to use engaging abutment. The anti-rotational feature is it's very good feature to have. So even if you are making cement retained fixed implant supported fixed partial denture, you have to use engaging abutment if it's cement retained, because it's going to be the abutment, they go first regardless of the restoration. I hope you understand the difference. Talking about the upper part, so those abutments, they can made out either zirconia or titanium, or the mix, the two piece, which is the base will be titanium and the coronal part will be zirconia. Let's say coronal part will be zirconia. So this is in terms of material. This abutment as well can be custom and can be stock. Let's write it here. Stock abutment. And each of these you can make a screw retained or cement retained as well. You can make a screw retained restoration from a stock abutment, or you can make cement retained of the abutment as well. So the custom abutment, how you make a custom abutment, you can mill it. So it's called CAD CAM abutment, or you can cast it, similar to the one that I showed you earlier, this guy. The stock abutment, if you're making, they come in two shapes. They come like tapered. We're talking about cement retained now. Let's talk about cement retained. They come in two shapes. They come like that, tapered, and they come straight, parallel wall. Guess what? This is the Variobase. So the Variobase, as you can see, it's designed from stock abutment, and you cement your restoration on it. If you're making porcelain fused to metal PFMs, your crown could be cemented on tapered abutment. They tried porcelain fused to metal on this design, it didn't work. This design only, parallel wall only works for all ceramic material like zirconia or lithium disilicate. The stock screw retained restoration as well is Variobase. You can make screw access here and access the screw. And I hope this is a good summary for abutments. So let's take, honestly, I'm gonna cross this out. This is wrong here. Cement retained, it should be for porcelain fused to metal. If you want to do screw retained out of stock abutment, it should be Variobase. There is no cement retained version of Variobase. Sorry for the confusion, guys. So again, Variobase is a stock abutment for a screw retained restoration, and this abutment it's called as well tie base because it's a titanium base. Let's get rid of that page now and move forward to our exercise. So before you start removing the tissue moulage, mark the lingual aspect. This is permanent marker because you need to be able to put it back in the same orientation, otherwise it will break on you. Just flick it off like that. Then you will attach your Variobase to the implant, and you need to see that they latch on each other. You need to rotate until they go in. Yep, that's securely there. And then with the screwdriver, yeah, we have limited screwdrivers in the sim clinic. I ordered 10, but hopefully they will be here by Friday. But if we have limited screwdrivers, just put it like that without the screw and work with it. But you can attach the screw. Goes in. The reason why we remove the tissue moulage to verify the seating of the melt crown. Sorry. Now this is the melt PMMA crown. Again, for simulation clinic exercise, it should be fine. If it was zirconia and the lab designed one crown for you, it will fit directly there with no gaps, like a glove. It will go all the way down. But as I said, since we are 80 students, things get mixed up and we have to do some adjustments. So as you can see, it doesn't go in completely. You can see the gap between the crown and the Variobase margin. Let me try to zoom in. You can see it from the bottom. So what I'm gonna do, there is anti-rotational feature as well inside. So before you start doing that, again, mark the buckle aspect of your temporary abutment, just in case you have to take it out, so you know the orientation of your abutment. Mark the buckle surface of your abutment. Believe me, it's gonna help you if you want to take the abutment for some reason out. So with the diamond bear, I'm gonna try to gently touch the inside of that crown. Again, this is not allowed in real case scenarios, but things are mixed up here. Let's try again. Getting closer. The gap is getting smaller. Get it out. You can see the metal marks there. That means it's touching there. Take it a little bit. Now it sets perfect. So you have to be gentle when you adjust. You can see there is no gap between the abutment margin and the restoration. They fit really nice. Now before you cement the crown to the abutment, it's worth to check the proximal contact if they need some addition. So on the cast, it's dragging shim stock. Very nice. Let's check the distal contact. Again, nice drag there. And because I don't have space here, but as well check what's holding shim stock without the crown. Put the crown in and make sure everything is holding shim stock, your original contact and the restoration. If it needs some adjustment, in the lab they will bake porcelain on the restoration. But for this exercise, you can flowable composite and fix the occlusion or proximal contact. So after you verify the contact, occlusal contact, proximal contact, and eccentric contacts, you move the jaws side to side, and hopefully you have canine guidance. You have no lines on eccentric movements. Now it's time to cement this crown to the abutment. So cementation process in the lab, they're gonna use resin cement. Again, for simulation clinic, we're gonna use the occlusion or the bite registration material. This is bite registration material. I'm gonna read some. Maybe you will see in one of the slides you can use fit checker. I tried fit checker, it doesn't work. See, I forgot the orientation here. clean the cement. So he made a mess. I wish if it was resin cement, it would be nicer. It would look nicer. Anyway, we're gonna wait until the cement sets on us. You can. This is nice material. You can clean it. Clean with the axis. It's easy to clean it. I think it's set now and ready to take it out. Be careful, don't lose the screw. Sometimes you just walk on it and the screw drops on you. You need the screw. By the way, all the parts need to be returned to me by Monday, December 13th. All the parts, otherwise your grades will not be uploaded to Icon. Even this part here, you're gonna use the air chisel to fish it out. So you're gonna break the cast and take it out. But this is gonna be after you finish your exercise and graded by your faculty. All the parts should be returned to the boxes and returned back to me. So now the crown is cemented and ready to be delivered to the patient. So let's see how this looks in the patient mouth. Hopefully your root plug, your implant is cemented with the light body, so it didn't move from the time you made the impression to the time you are delivering the crown. If you borrowed your friend root plug, there is only two ways to fit this in, either this way or that way. So you have two options, and you have to find which one did you use. So if you notice, I expanded my root plug a little bit. As you can see, I didn't touch the implant platform here. I just expanded the plastic around it. And you have to expand it wide enough. See, I'm gonna just touch it a little bit more. Expand it there, mesial areas, even I lost the mesial areas while I'm trimming. Again, this is not compressible tissue. Remember, my technician designed it on the tissue moulage, so he was expecting some expansion, but this is plastic. So now I'm going to take the crown and deliver it to the patient. Mark. This is the fascium, this is the ligament. Going to check the proximal contact. Nice drag. Nice drag. Find my reference contact. Hold. 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 First thing I check is the original content. Hold, hold, hold. Nice. Now hopefully my implant crown is holding. Let's check that. It is holding. Good. That means it's ready to be delivered. So I will take my screwdriver first. Always, this is the rule. You have to hand tighten it first. And torque. Then we're going to use the torque wrench. Strowman torque wrench comes in 3 pieces. I don't know why. Other implant companies, they have only 1 piece to make the torque wrench. So it's a puzzle. This guy should go inside this guy. They call it the barrel. Pay attention to the orientation. I don't know if you see that, but it has to go. You cannot put in this orientation. It should be this side. And this goes from the back. And you unscrew that. All the way in. Now this is ready. So you see this is small arrow there. It tells you this is, if you move this way, that means clockwise you are torquing parts. If you flip this to the other side, that means the movement should be this way and you are untorquing parts. It's the thumb rule, if you are familiar with that. So clockwise or anti-clockwise. So we're gonna put it on the clockwise mode because we're torquing our restoration to 35. I don't know if you see the numbers, but this is 35. This is 0, 15 for temporary components, and 35. So those, they're gonna go inside. Now it's latching. You see the clicks. It's working. The torquing technique is you're gonna put some pressure on the head. Now it's engaging. And you're only allowed to touch the teardrop. Don't ever touch the shaft. Then you start. You can see that the torque values are increasing. Give it. You can go back and torque more. Now we reach 35. You do it 3 times. Sometimes I wait 10 minutes and torque it again, but simulation environment should be fine. Now the torque is good. You can check back the occlusion, make sure it's comfortable to the patient. Now to close the screw axis, we have Teflon tape. You can use gutta percha as well, but I like Teflon tape. Very easy to use. You cut small piece because we need to protect the screw head in case if we need to take the crown out at any point. So you just roll it like that. Push it all the way in. it's condensable material. If you have a lot of excess, you can take it out, cut, because you want room for your composite less than 2 millimeter, that you will compromise the material strength. And if, as you know, the shim stock was holding because I know it was occluding at this marginal ridge. It was not occluding. So my occlusion is protected by permanent material, which is the zirconium. This is the screw axis is not compromising the occlusion or the aesthetics. I'm gonna close the hole with composite. Let me go and cure it. Give it a quick cure. I always use a different shade for ease of identification. Later, if I want to access the implant, I can easily notice the screw axis without compromising the crown integrity or crown material. Occlusion is checked. Good. Very good. And yep, you can polish that before you deliver it. You can polish it, make it shiny. So yeah, this is all what I have for you guys. Again, don't forget to turn your parts, everything. After, in the sim clinic, you don't need to torque or put Teflon tape. Just let your faculty check the occlusion once you cemented with the occlusion registration material. Thank you and a good night. Have a good night.